So, now, we've been talking lately about this mole map, about going from mass to mole to mole to mole to mole to mass, or just going from mole to mass, things like that. We've kind of forgotten about the volume of the particles. They're there as well. Whenever you work with a gas, typically we work with volume. If we're talking about something more molecular, it's going to be the particles. Okay? So today we're going to look at just a couple of those. We have a test on Tuesday. We'll be going over doing some review stuff on Monday, finishing up the lab. But I will not be here Tuesday, so that's when the test day is. Okay, that way we don't have to worry about anything. Yes?
Do you know who our results going to be?
Miss Beaner. Yes. Okay? So, if I have this 2H2 gas plus 1 O2, I like using this as gas, it's easier, yields 2H2O liquid. So I'm going to make, I need to know how many grams of water I'm going to make if I put in 1.14 liters of hydrogen, and let's just say 1.14 liters of oxygen, equal amounts. Okay? So what I have to do is do a volume to mass for this equation. So we'll start with hydrogen, 1.14 liters of hydrogen times 1 mole of hydrogen over 22.4 liters, that's an L there, times 2 moles of water over 2 moles of hydrogen, thank you, times 18 grams of water over 1 mole, H2O. Okay? Then I'm going to set up the other one, 1.14 liters of oxygen, 1 mole of oxygen over 22.4 liters times 1 mole of, not like 2 moles of water, H2O over 1 mole of oxygen times 18 over 1 mole of water. Okay, so let's do the math here. So 1.14 times 2 equals times 18 divided by, whoops, my bad. 1.14 times 18 divided by 22.4. So this is 0.92 grams of water. And then 1.82. Is that what you said? So 1.14 times 32, then 36 equals divided by 22.4. Yep, 1.83. So how much water will I make? How much water will I form in this reaction? 0.92 grams. So 0.92 grams. Does that make sense?
Yes.
Did I have to go through all the mole map stuff with you? Did you need that? No, it's pretty straightforward. Okay, so this is going to be my limiting reactant. And this is my excess. Does that make sense? Yes?
Yes.
Okay, so I know that this limiting reactant is going to limit not only how much water I make, but it's also going to limit how much oxygen it reacts with. So there's an excess of oxygen. So we're going to say, okay, how much oxygen, Sean, should I have used? What are you doing back there? Okay, pay attention. Okay. So I'm going to start with my 1.14 liters of hydrogen again. Now I want to go to liters of oxygen. Okay? I want to know how much I should have used. So 1 mole or 22.4 liters 1 mole of oxygen over 2 moles of hydrogen. Goes back to 22.4 liters of oxygen over 1 mole of oxygen. The funny thing about that is this, look, 22.4 on the bottom, 22.4 on top. So basically it's a molar ratio still. So basically I have 1.14 divided by 2. So what's 1.14 divided by 2? Sorry? Okay, 0.57 liters. 7's upside down. 57 liters. That's how much I should have used. Okay, Trent? Should we write this stuff down, bud? Sit up. Okay. So I put in 1.14 liters of oxygen. I should have only used 0.57 liters. So how much do I have left over?
0.57.
Good. 0.57 liters left over. Does that make sense? So that's how you find the excess. You use your limiting reactant to go back and do another stoichiometric equation and figure out how much you should have used of this. Yes? Are you good with that? Now, let's say we have Sebastian as a partner and for Tim, and we say, just kidding, and we say, okay, you guys did this lab, and you made, in lab, you made 0.64 grams of water. Okay? And I would say, okay, what is your percent yield? Percent yield is just kind of a test score almost. What you got over what you should have got times 100. So I would call it experimental over actual times 100.
69.5%.
So they would have had a 69.5%. They would take 0.64 divided by 0.92, whoops, times 100. Percent yield is just how much you actually made versus what you should have made. Make sense? Okay. Well, today you're going to do a lab where you're going to determine the percent, you're going to determine the limiting reactant, then you're going to determine your percent yield, and you're going to think about other things it requires. Excess, we're going to do excess. Okay, all in one lab. Fun? Yes.